Hi guys, today we are going to discuss about series circuit. I also draw the same circuit on the page and the same circuit is on the breadboard. This Arduino is just for because the breadboard is already attached on the same place. So input we are taking here 9 volt and remaining our circuit is in series. Series circuit is like in a circuit in which components are connected in series. There is no parallel things here. Everything is in series. The beauty of the series circuit is the all the components which are connected in series, the current flow will be same from each component, and I will show you the all these things on this multimeter. Okay, let's start with the value of a resistor which we are going to use here. I already know the value here, it's 220 ohm, and we can find out the value of resistor. Let's see, we put this knob at resistor area or resistance area of the multimeter. So we can figure out that the resistance is around 217. So it's like almost same. We 220 ohm you can see here, and okay, we already know the resistance. Now we have to figure out, now we are going to use the Ohm's law, which is equal to V is equal to IR. Let me change the PowerPoint. Ohm's law is like I is equal to V over R. So we can also we are going to put the values here for each component so we can find out the resistance, voltage and the current in the circuit. Our second step to measure the current in the circuit, and there is a way we cannot measure the current when everything is connected. For measuring the current, we have to first of all put the knob in around, because this is a small circuit, we are going to put the knob around here in ammeter amperes area. This is a ammeter, or it is multimeter. This area is for ammeter. And for measuring current, we have to plug out one leg from here and one leg. Okay, let it be attached, but we can do here. So we have to break the circuit. We cannot measure the current when everything is connected. So let's see. When the LED will blow, it means that it is connected. And we will also see the thing here. See, now the LED is glowing, and now we can measure the amperes here. So it's around 26.5 we can take. So our current, that is the total current. Total current mean like because in series we have the same current in circuit, so current is like 0.026 amperes, or in other way in milliamperes we can say 262 milliamperes. So this point will go 1 2 3 and it's go from here like this. Okay, so we know the current and we know the resistance. Now we can easily find out the voltage of this resistor. So normally current was around, we can calculate in amperes because we have the thing is in ohm, so we have to be in amperes for the calculations. So to be in amperes we have to be 0.026 amps into the resistance we calculated here, which was around resistance calculated was 218 ohms. So we are going to the same which we get from the calculation, 218 ohms. So we can also calculate it, or we can also measure the voltage of the circuit of this resistor. Let's reconnect the circuit because we break it for measuring the current. So we have to put the knob here, just have to focus here. We are going to put the knob here around here, maybe. Let's see. Now we can find, it will find, the multimeter will find the voltage. Voltage should be around 6. Let it's 5.88. If you can see clearly, the voltage was around 5.87 or 5.88. It's around 6. So we can also calculate it. Let me calculate it. So we figure out that we measure the voltage. As we measure the voltage, that was 5.88, and we also calculated the voltage that was around 5.668. Around about, we can take like voltage at the middle value 5.7 volts of resistor. So this is the one thing. So now we already know, we figure out that voltage of this resistor is around 5.7 volts. Okay, so now the first voltage, which is the complete voltage for the circuit, that was 9. Now we are using 5.7. In LED, we have to know that we can do it a calculation. 9 minus 5.7. As we can say from the calculation, the voltage for the LED should be around 3.3 volts, but it will not be 3.3 because why? We can also measure it. Let's see. It is showing around 2.09. Okay, so the voltage for LED is around 2.07, and this is the voltage from its resistor. This is the voltage from LED. In total, they are around 6 or 7, 8. Where is one voltage? Now, the voltage drops we can measure could be from, because we are using many wires here, so the power is coming from here, from the LED, yes, from the battery to this terminal, and from this breadboard terminal we are using another wire, and then we are using many wires, due to which the around one we can say one voltage, one point of voltage value could be dropped somewhere in between. So this is the whole calculation which we can do. We can measure we already measured the current, the total current which will pass from here and here for in all circuit, in complete circuit. We also measure the voltage, we also measure the voltage of LED. So this is the series circuit, and you can also see how we can calculate the current and the resistor and the voltage by using our multimeter. Why we are saying it as a multimeter? Because this area is for calculating voltage, this area, green area, is for calculating resistor, this area, another green area, it's also written here amperes. This is used for the measurement of current. That's why it is called multimeter, like a meter in which we can calculate many calculations. So this is the thing is in series circuit. In next video I will show you maybe some parallel circuits or some other circuits. Thank you so much.